Hey guys, good evening, and welcome back again to your Unacademy English channel. I hope all of you are doing great, having a good time. So, my dear students, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Let me know quickly in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know quickly in the chats, people. Let me know quickly in the chats. उज़ार ये JK बैच के लिए नहीं है. This is for the NEET English students. All right. So I think I'm perfectly audible, visible. So my dear students, as you must be knowing, today we are going to start. Today we are going to start the chapter that is going to be your redox reaction. I believe all of you would be knowing that. Yeah? I believe all of you would be knowing that. And as you know, we start every chapter from basics, from the scratch, right? So today's session, today's chapter, again will be started from the scratch. And this chapter will be for both Phoenix 2.0 as well as Phoenix 3.0 students. Okay? This chapter will be for both Phoenix 3.0 as well as Phoenix 2.0 students. I hope you know that. So basically, all the Phoenix 3.0 students, right? This is going to be their first chapter, and Phoenix 2.0 students, it's going to be their second chapter. Now, people must be thinking, Phoenix 3.0 students must be thinking, what about their first chapter mole? You'll be having extra class for that. You don't worry about that. Okay? Notes you are going to take down with me. Notes you are going to take down with me. All right? How many lectures for this chapter? I will be taking almost 7 to 8 lectures for this particular chapter. 7 to 8 lectures I'll be taking for this particular chapter. All right? No need to worry. Every single thing will be started from basics. Every single thing will be started from the scratch. As you know, this is our first session. Yeah? No need to worry. And we always keep the duration of first session small, right? So the duration of this session also will be almost like 40 minutes. And you know the first class of every chapter we take on YouTube, right? Well, that graph session which I took, that's not mandatory for all. That is just if you want to get benefited more, you can watch that session. Yeah? Chalo, should we start, people? Should we start? Everyone, I would want some fire emojis in the chats. I would want some fire emojis in the chats, people. Everyone. Everyone means everyone. Everyone means everyone. And I do not want anyone to write anything in between. Okay? I know a lot of you would be asking about, sir, when is the Telegram group getting created? Telegram group will be created day after tomorrow in my session, which I'll be taking on the Unacademy platform. Okay? Day after tomorrow's session, right? I will create a Telegram channel for you, wherein you will be remaining in contact with all of us, all the educators, basically. Perfect? Whatever doubts you have related to notes, related to your study material, related to tests, anything, all those things I'll be discussing in my next session, basically. That is day after tomorrow, which will happen on Unacademy platform. First session, we always keep free for everyone, right? So whether you are the part of this batch or not, you can still have a look on this particular session, right? And those students who still would want to get enrolled in the Phoenix 3.0 batch, you are most welcome because the batch started. Like this is my first class in the Phoenix 3.0. Perfect. So all those students who would want to get enrolled in the batch, you can still enroll. The link is there in the description. The link is there in the description. You guys can still enroll into the batch. And the batch features your entire syllabus completion of physics, chemistry, biology will be done by January end. After that, 2 months of revision. Regular tests after every 14 days, right? No need to worry about the test series. No need to worry about the study material. Every single thing is provided. DPPs, one-on-one mentorship, every single thing, people. Okay, so if you still are thinking to get enrolled into the batch, you guys are most welcome. Okay? And I can see not everyone has smashed the like button yet. Yeah? Not everyone has smashed the like button yet. So you know what to do before the start of the session? You know what to do before the start of the session? Smash that like button quickly. My class, I take class on alternate days. I take classes on alternate days, not every day. Basically, technically, if you say, let's say Monday, I take class in English batch. Tuesday, I take class in J&K batch. Then again, English batch, J&K batch. English batch, J&K batch, like that. Hello, Shivaraj. Hello, hello, hello. Perfect. Hello, let's get going. Let's get started, people. The name of the chapter, whose first lecture I'll be taking today. The name of the chapter is one of the important chapters, a redox reaction. Redox reactions. This is the name of the chapter which we are going to do today, my dear students. All right. Well, before the start of every chapter, I give you the list of the topics. I give you the list of the topics which we shall be completing in the chapter. So let me first of all give you the list of the topics which we have to cover in this particular chapter, people. Okay? So basically, I'm going to give you the table of content first of all. And what is the table of content? Let me tell you the first topic that we shall be discussing in this chapter, that is going to be your oxidation state. That is going to be your oxidation state. This is going to be the first topic which we shall be covering here in this particular chapter. Oxidation state. Once we are done with the definition of oxidation state, etc., we shall be talking about the rules to calculate. The rules to calculate the oxidation state. Then we shall be discussing the oxidation state from structures. Oxidation state from structures. Then we shall be discussing oxidation and reduction. Oxidation and reduction. Once we are done with oxidation and reduction, then it's going to be the time for oxidizing agents and reducing agents. After that, we shall be discussing the applications of oxidizing reducing agents. Applications of your oxidizing reducing agents. Once we are done with that, we shall be moving into the topic called as equivalent mass. Equivalent mass. And right after that, we shall be discussing about the N factor calculation. N factor calculation. And once we are done with the N factor calculation, my dear students, we shall be moving into what? We shall be moving into we shall be moving into the reactions of KMnO4 and K2Cr2O7 in acidic medium. In acidic medium. And once we are done with the reactions of KMnO4, K2Cr2O7 in acidic medium, then I shall be discussing the topic balancing of redox reactions. Balancing of redox. Once we are done with balance of redox, we'll be discussing the concept of equivalence. Concept of equivalence. Right after that, we shall be discussing about the law of chemical equivalence. After your law of chemical equivalence, it's going to be your redox titration. After your redox titration, it's going to be your acid-base titration. Acid-base titration. And my dear students, the last topic which we are going to cover here, that's going to be the volume strength of H2O2. Well, with this, our first chapter will get completed. Okay? All right, people? Got it? This is the list of the topics which we shall be covering in the redox reaction chapter. One thing I forgot. Types of redox reactions. Types of redox reaction. Okay, that is the topic which I shall be discussing at the end of the chapter. Because that's a theoretical topic, simple topic. Perfect. Should we start then? Should we start already? Yeah? All right, people. So let's get going. Let's get started with the topic. And the name of the topic is your oxidation state. Oxidation state. My dear students, first of all, if you ask me, how do we define the term oxidation state? How do we define the term oxidation state? Let me write few lines about oxidation state first, then I'll make you understand what's the meaning of those lines. But whatever things I'll be writing on the screen, I want you guys to take down everything with me only. Okay? So oxidation state is nothing but it is defined as the charge present on an atom. The charge present on an atom of an element in a given compound. The charge present on an atom of an element in a given compound. What is meant by that? You'll understand in some time. Point number 2. The charge can be real or virtual. The charge can be real or virtual. Point number 3. A real charge arises in case of ionic compounds. A real charge arises in case of ionic compounds, whereas virtual charge arises in case of covalent compound. In case of covalent compound. The next point, my dear students. A real charge is due to the complete loss or gain of electrons, and virtual charge is due to the electronegativity difference. Electronegativity difference between the atoms. or you can say between the bonded atoms. And one more point. Oxidation state is defined. Oxidation state is defined for one atom of an element. Well, these are the few points, my dear students, which you need to know about the oxidation state first. Okay? Let's try to understand all these points one by one. Let's try to understand all these points one by one, people. Now, first of all, try to understand what exactly I'm going to say. See, guys, let's try to understand the concept of oxidation state. My dear students, for example, imagine that you have got an ionic compound. Imagine that you are going to take an ionic compound. Can you tell me one of the most common, one of the most typical examples of ionic compound? The most typical example of ionic compound is basically your NaCl. Most typical example of your ionic compound, NaCl, right? In case of your NaCl, my dear students, if I ask you, how many elements do you see? I can see two elements, sodium and chlorine. I can see two elements, sodium and chlorine. My dear students, as you all must be knowing, this sodium, it is a metal. And when I talk about chlorine, chlorine is a non-metal. Sodium is metallic in nature, chlorine is non-metallic in nature. Now, since sodium is metallic, and you know, metals have got the tendency to lose electrons, whereas non-metals have got the tendency to gain electrons. Metals have the tendency to lose electrons, whereas non-metals have got the tendency to gain electrons, right? Metals have got the tendency to lose electrons, whereas if I talk about the non-metals, non-metals have got the tendency to gain electrons. Now, my dear students, if I talk about the formation of NaCl, if I see exactly how NaCl gets formed, if I see exactly how NaCl would have got formed, if I see exactly how NaCl would have got formed, have a look. Since if I talk about sodium, sodium is metallic. It has got the tendency to lose electrons. Now, you know, if I talk about the electronic configuration of sodium, it is 2, 8, 1. Electronic configuration of sodium is 2, 8, 1. Now, tell me one thing. Is it easy for sodium to gain 7 electrons? Or it is easier for sodium to lose 1 electron? I would say, in order to get the stable configuration, it is easy for sodium to lose 1 electron. So what I'll say the sodium would have got converted into Na positive and it would have given away 1 electron. Since if I talk about sodium, in its outermost shell, there is only 1 electron, right? So it is easier for sodium to lose 1 electron and get converted into what? Get converted into Na positive, right? Get converted into Na positive. Similarly, my dear students, if I talk about chlorine, the outermost configuration, the electronic configuration of chlorine. You know the configuration of chlorine, that's 2, 8, 7. Now tell me one thing. Whether it is easy for chlorine to lose 7 electrons? No. It is easy for chlorine to gain electron. Gain 1 electron to get the stable configuration. So basically, this electron which is given by sodium, I would say chlorine will be gaining this 1 electron and will get converted into Cl negative. Okay? So first of all, my dear students, sodium has lost 1 electron, got converted into Na positive. Chlorine has gained 1 electron, got converted into Cl negative. Now what is going to happen after this? What is going to happen after this? I would say, since sodium got converted into Na positive and chlorine got converted into Cl negative, my dear students, do you see equal and opposite charges species over here? Absolutely. I can see equal and opposite charges species over here. So if there are equal and opposite charges species, can I say there will be electrostatic force of attraction between them? Absolutely. And my dear students, this electrostatic force of attraction between these oppositely charged ions, this electrostatic force of attraction between these oppositely charged ions is something I would call the ionic bond. It It is something I would call as ionic bond. Either you will call it as ionic bond or you can call it as the electrovalent bond. You can call it as the electrovalent bond. You can call it as the electrovalent bond. Now, my dear students, if I want you to look at this NaCl, if you look at NaCl, when you saw the formation of NaCl, you got to know that sodium here is in the form of Na positive, and in reality, chlorine here is in the form of Cl negative. Then there is force of attraction between them, and that force of attraction we call as the ionic bond. Now, people, if I ask you, what is the charge present on one atom of sodium here? The charge present on one atom of sodium, as you can see, is nothing but +1. And the charge present on one atom of chlorine here is -1. And let me tell you, the charge present on one atom of an element, is what we call as oxidation state. So you would say the oxidation state of sodium here in NaCl is +1, and the oxidation state of chlorine over here is -1. Yeah? I believe I'm clear. If yes, let me know once quickly in the chats. Right? Perfect. The charge present on one atom of sodium is +1. The charge present on one atom of chlorine is -1. And you know, the charge present on one atom of an element, is what you call as the oxidation state. My dear students, do you see one more thing? What is that one more thing? Do you see? Sodium lost one electron completely, and chlorine gained that one electron completely. Sodium lost one electron completely, and chlorine gained that one electron completely. So can I say, over here, complete loss and gain of electrons is happening? Absolutely complete loss and gain of electrons is happening. And let me tell you, whenever the charge arises on the atoms due to complete loss and gain of electrons, these are going to be the real charges, basically. These are going to be the real charges. What is meant by real charges? See, this +1, it indicates that sodium has lost one electron completely. This -1, it indicates that chlorine has gained one electron completely. So remember, due to complete loss and gain of electrons, real charges would arise on the atoms. Right? Perfect. So real charge arises on the atoms because of complete loss and gain of electrons. A real charge is due to the complete loss or gain of electrons. Okay? Perfect. Now, my dear students, understand a few more things. For example, imagine that you are taking a covalent compound. Leave the ionic compound aside. Let's say you are taking the covalent compound into consideration. Well, you know, in case of covalent compound, there will be mutual sharing of electrons. You know that already, right? Let's say, my dear students, you have got a covalent compound like this. This is A single bond B. It's a covalent compound, for example. So there should be mutual sharing of electrons. If there should be mutual sharing of electrons, that means the electron pair, which represents your bond, the electron pair, it should be exactly present at the center. Since there is mutual sharing of electrons. The electron pair, the bond, since bond consists of two electrons means an electron pair, right? So I would say the electron pair should be present exactly at the center. But my dear students, imagine that the electronegativity of B is more than that of A. Now think over it. If electronegativity of B is more than that of A, that means this B has got more tendency to attract this electron pair towards itself. Due to which the electron density towards B will increase. And that increase in the electron density towards B, I'll be representing with minus delta. Electron density towards A has decreased, and that decrease in the electron density towards A, I represent with plus delta. Right? Perfect. Now, my dear students, if you ask me, what is the oxidation state of A here? My answer will be +1. What is the oxidation state of B here? My answer will be -1. But does this +1 indicate that this A has lost 1 electron completely? No. Does this -1 indicate that B has gained 1 electron completely? No. My dear students, this -1 indicates only one thing, that the electron pair, which was supposed to be at the center, now it's not exactly at center, it's closer towards B. This +1 indicates that the electron pair, which was supposed to be at the center, it is not going to be at the center, it will be closer to B. It will be away from A. It will be away from A. Right? And my dear students, whenever charges arise on the atoms, due to the electronegativity difference between the atoms, these charges I call as the virtual charges. So virtual charges arise due to the shifting of electron pair. And the shifting of electron pair between the bonded atoms is due to the electronegativity difference. Right or right? Absolutely right. Yeah? Okay. For example, if there's a double bond between A and B, imagine that there's a double bond between A and B. If there's a double bond between A and B, one bond consists of one electron pair. Similarly, one more electron pair. So technically, if there's a covalent bond, so I would say these two electron pairs should be exactly at the center. But what we have assumed? We have assumed the electronegativity of B more than that of A. That means both the bond pairs will be shifted. Both the electron pairs will be shifted towards what? Towards B, due to which B will get the charge of -2 delta, A gets the charge of +2 delta. So if I ask you, what is the oxidation state of A here? You'll say +2. What is the oxidation state of A here? That is, sorry, B here, -2. Does this -2 indicate B has gained 2 electrons completely? No. Does this +2 indicate A has lost 2 electrons completely? No. It just means that the electron pairs, which were supposed to be at the center, they have been shifted towards B, due to which these atoms got the virtual charges, not the real charge. Right or right? Quick. Quick, people. Everyone in the chats. All right. Amazing. I'm just teaching you the basics of the things right now. Got it? Perfect, people. Perfect. Perfecto. Perfect. Amazing. Now, guys, one more thing. For example, there is a triple bond between A and B. If there is a triple bond between A and B, I would say oxidation state of B would be -3 and the oxidation state of A would be +3 because B is more electronegative. All the 3 electron pairs would be towards B. Yeah? All right, let me take few examples as well. For example, you have got a compound HCl. You have got a compound HCl, a simple compound, right? A simple compound HCl. Now, my dear students, one thing I would want you guys to remember from now onwards, in your periodic table, the most electronegative element is your fluorine, followed by oxygen, followed by nitrogen. The most electronegative element in your periodic table is fluorine, followed by oxygen, followed by nitrogen. This is something which you should know, right? Right? Again, one more thing, my dear students. In your periodic table, when you move from left to right, what happens to electronegativity? Electronegativity increases. In the periodic table, when you move from left to right, electronegativity increases, right? And similarly, my dear students, in the periodic table, when you move from top to bottom, electronegativity decreases, right? This is the general trend which you see. Yeah, this is the general trend which you see already, which you would be knowing also. Okay. So on moving from left to right in the period table, electronegativity increases. On moving from top to bottom, electronegativity decreases. This is something which I would want every one of you to remember. Now tell me, among hydrogen and chlorine, which one is more electronegative? Chlorine is group 17. Hydrogen is at the extreme left top periodic table. Extreme left. Chlorine is almost at the extreme right of the period table. Which one is more electronegative? Chlorine. If chlorine is more electronegative, so chlorine will get delta negative, hydrogen gets delta positive. So if I ask you, what is the oxidation state of hydrogen here? Your answer will be +1. Oxidation state of chlorine here, it is going to be -1. So what is this +1 and -1? Does +1 mean hydrogen has lost 1 electron completely? No. Does -1 mean chlorine has gained 1 electron completely? No. It is just the electron pair has shifted towards chlorine. That's it. Simple. So how I'm going to represent it? I'll just write it like this. HCl, hydrogen has got the oxidation state of +1 and chlorine has got the oxidation state of -1. Now similarly guys, for example, I believe all of you know about water, the structure of water. This is the structure of your water, right? How many bonds do you see? I would say there are 2 bonds. This is your first bond between oxygen and hydrogen. Among oxygen and hydrogen, which one is more electronegative? I would say oxygen is more electronegative. If oxygen is more electronegative, this bond pair will be shifted towards oxygen. And when bond pair is shifted towards oxygen, oxygen gets delta negative, hydrogen gets delta positive. Because of this bond also, again, oxygen gets delta negative, hydrogen gets delta positive. So if I ask you, what is the oxidation state of this hydrogen here? Your answer will be +1. Oxidation state of this hydrogen here, your answer will be +1. Oxidation state of this oxygen here, your answer will be -2. Right? Perfect. So, if I write simple H2O, tell me one thing. What is the oxidation state of hydrogen in water? Is it +2? Is it +1, +1, +2? What is the oxidation state of hydrogen in water? Is it +1, +1, +2? No. Oxidation state is defined as the charge present on one atom of an element. The charge present on one atom of an element. I'm asking you, what is the oxidation state of hydrogen in water? That means I'm asking you, what is the charge present on one atom of hydrogen in water? And the charge present on one atom of hydrogen in water is nothing but +1. So that means hydrogen here is in +1 oxidation. And oxygen here is in -2 oxidation. Okay? For example, I've got the compound like this, A2BC. A2BC. I'm writing oxidation state of A here is +5. What does it mean? I'm writing oxidation state of A here is +5. It means that the charge present on one atom of A is +5. It means that the charge present on one atom of A is +5. So remember your oxidation state. It is defined for one atom of an element. Okay? Similarly, guys, for example, take the case of water. Take the case of NH3. This is N, this is H, one more H, one more H. This is your NH3. Now tell me, this particular bond is between nitrogen and hydrogen. Which one is more electronegative? I would say nitrogen is more electronegative than hydrogen. So this bond pair gets shifted towards nitrogen, minus delta plus delta. This bond pair also, minus delta plus delta. This bond pair also, minus delta plus delta. So tell me, what is the oxidation state of this hydrogen here? +1. Oxidation state of this hydrogen here? +1. Oxidation state of this hydrogen here? +1. Oxidation state of this nitrogen here? -3. Right? So when you talk about your NH3, nitrogen will be in -3 oxidation state and hydrogen will be in +1 oxidation. Perfect. So I believe whatever things I told you till now, every single thing is clear to everyone. So look at the things quickly I discussed with you. Oxidation state. It is defined as the charge present on one atom of an element. It is defined as the charge present on one atom of element. Now the charge can be real as well as virtual. In ionic compounds, the charge is real. In covalent compounds, the charge is virtual. real charge arises due to the complete loss and gain of electrons, whereas virtual charge arises due to the electronegativity difference between the atoms, right? And oxidation state, that is basically defined for one atom of an element. Did you understand the meaning of the term oxidation state? Am I absolutely clear to everyone? Yes? So this was a simple session which I took on YouTube today for everyone, right? As you know, we keep the duration of the first session almost 40 minutes only. So I just discussed some basic things with you. The actual stuff will be discussed in my lecture, which is scheduled day after tomorrow on the Unacademy platform. Okay? All those students who still would want to get enrolled in my batch under my mentorship, you can see the link there in the link is pinned in the chats. Okay? Just click on the link if you want to be the part of my batch. Click on the link, get enrolled, because today I just have discussed some basic things. From day after tomorrow, I'll be discussing the actual things with all of you. Okay? And also at the end of this particular session, once this session ends, I would want you guys to comment in the comment section, like how did you like this particular session? Okay? I would be checking your comments. With this, I'll be taking a leave. You take care. God bless you all. I'll see you in my next session, which is scheduled day after tomorrow. Okay? And if you're not the part of the batch yet, be the part of the batch as soon as possible, right? Because in the batch, you know, I've discussed already, I've told you already, your entire syllabus of physics, chemistry, biology will be completed by January end. Tests after every 14 days. Study material, the level of study material we provide you in the batch itself, right? This is the study material basically which we provide you in the batch itself. Perfect. These 23 booklets which will be delivered to your houses if you are going to take the Iconic subscription. Yeah. And similarly, no need to worry about the All India test series. Every single thing is planned. Revision classes in the month of February, March. Access to all the batches of Unacademy. That's also there. If you are going to be the part of this batch, you'll be having the access to all the batches of Unacademy for the NEET 2027 preparation. Okay? Chalo, guys. Chalo. With this, I'll be taking a leave. I'll see you in the live session. Take care. Bye-bye.